Good morning, South Africa and my fellow MDMSA members. In part 2 of our technology series with How It's Made Today, we explore how contact lenses are made as a medical device and the raw materials used in manufacturing them. I know you will enjoy this interesting video as I certainly did. From me, Dr. Kumalo and the team at MDMSA have a great day.
While they may seem uncomfortable to non-contact wearers, contact lenses are amongst the most advanced and successful technologies out there. They are flexible, don't get in the way, and are more effective than glass, and reduce the possibility of infection. But how does such an incredible and advanced thing get made? Let's find out. Getting the right raw materials. Nowadays, there are a few types of lenses to choose from, and these mostly differ in material used to make them. For example, there are the most common hard lenses, which are made of polyhema plastic, a relatively elastic, that tough material doesn't get damaged so easily. Then there are soft ones, made like a gel-like plastic, which are cheap, disposable, and more comfortable. There are even midway lenses nowadays, which are made of a combination of these materials. And while all of them have their importance, today we're going to be talking about the first kind, hard lenses. Now, the raw material for these lenses is brought into the factory in form of long rods, roughly the diameter of the largest lens. These rods are actually already colored, blue, brown, white, or any desired color that our user may desire. And while the exact chemical combination might differ from company to company, all of them are supposed to have uniform optical qualities, the ability to retain their shape and composition, and finally the ability to absorb water, which is an essential for the lens to be able to stick to the eye. This brings us to the manufacturing stage, whose first step is Step 1. Prep. Now, it's no secret that each set of lenses is unique to the wearer, which is why you can't just go and order a standard factory lens. Instead, for each set of eyes, unique measurements are supposed to be taken that are crucial to the size, shape, and other properties that make the lens usable. These measurements include stuff like eye thickness, the size of the cornea, the exact optical number of the eye, and even any tiny imperfections that might be on the eye surface. All of this is done by an optometrist with a specialized equipment, and once the prescription has been recorded, with all the color and material preferences, the information is sent to the factory, which is where we move on to the next step. Step 2. Compulsorized lathe. At this stage, all the prescription data and any other requests are fed into a computer that controls any and all automatic lathe machines. After that, the operator grabs the polyhema rod of the desired color and asphyxiates it to the lathe in preparation for the machine. The next step is to cut the inside of the curve of the lens into the material. This is done by rotating the lens a bit over 6,000 revolutions per minute and bringing it to the next industrial diamond bit. This ensures that A, the lens is cut without any imperfections, and B, it is cut super fast, and once the lathe has cut the groove, it does another pass to remove any remaining abrasions. Finally, for this step, the polymer bit is cut off from the rod and taken to the next step. Step 3. Polishing the insides. Now, this step is probably the most crucial, since this side of the lens that will be in the contact with the eyes, so it has to be absolutely perfect to ensure that the wearer does not face any discomfort while wearing or taking off the lens. As for how it's done, the individual bit from the previous step is now glued to another machine, where a micro-abrasive paste is put into the inside. Then the machine places the lens on top of a rounder polisher, where it spins around fast enough to smooth out the surface. And once those insides have been inspected and cleaned, we move on to the next step. Step 4. Waxing and lathing the outside. This step is pretty much a repetition of the inside machining, but for the outside, only this time since the inside has already been made. To fix it, it is glued to the lathe using a special warm wax. Then, it is pretty much the same. Diamond drill bit, 2 passes, one to achieve the desired thickness, another to achieve the curve, and voila! The lens is part of the lens is complete. Finally, the entire bit is machined on one last time to bring the lens diameter to match the wearer's cornea, which is done using the same diamond bit, and the now separated lens is brought into the next stage, which is Step 5. Polishing the outsides. Just like the inside, the time for the outsides are coated for the abrasive paste combined with some oil, and since it's a convex shape instead of a convex one, instead of a round polisher, a fine polyester cotton ball is used for the final step. After that, a worker then polishes the rim of the lens, completing the fabrication. After this comes the longest and probably the most boring part of the lensing making process. Step 6. Hydration. Now, as slow as the process is, without proper hydration, a lens is basically unusable. Why? Well, you see, the polymer of the lens is actually made out of a pretty dry and hard metal material. So, to make it actually usable, the lens has to be soaked in water for a whole 24 hours before the lens becomes both flexible as well as larger in size. This results in characteristic sticky, smooth, and rubber-like lenses most of us are very familiar with, and once the desired material state and size are achieved, we move on to the second last step. Step 7. Testing. This is also a very important step, as if it's not tested properly, a slight error can cause long-term consequences for the wearer. As a result, before the lens is deemed complete, it undergoes a few testing methods ranging from a simple visual inspection, a test using an optical telegrapher, to verify the uniformness of the optical power, as well as the shape of the lens, and finally, 2 simple tests, one to measure the exact power of the lens, and a frontal focal meter test to verify the lens precision. And once a batch successfully passes the test, it leaves the manufacturing stage onto the last one. Step 8. Finishing touches. At this level, all the lenses are separated into the original pairs, which each pair being into containers, filled with a salt solution, which not only keeps the lenses wet, but also makes sure that no germs or other microfibers collect on them. These vials are then preserved for either shipping or kept in storage until they are needed. And as last preservation measure, before they are sent away, they are all sterilized at 121 degrees centigrade for 90 minutes before being sealed with a plastic seal and an aluminum cap. And that's basically the entire process. From start to finish, each individual lens takes almost a whole day to make, but if you exclude the 24-hour hydration, it only takes 15 minutes from raw material to the finished lens. Add to the fact that due to their sizes, lenses are made in batches of hundreds of a time. It's not a surprise that most contact lenses can push out 1,000 complete contact lenses a day, making the entire process definitely worth it. Let's take a look at the history now. History. Contacts have actually been around for almost the same time amount that glasses and other eye treatments have, believe it or not. In fact, the first contact lens was made all the way back in 1887 by German philosophist Adolf Flick, but back then, those lenses were also just made of glass, fit over the whole eye, and were ridiculously and uncomfortable to wear. It was only in 1912 that Carl Zeiss was able to make the first modern glass concealed lens, which is called that because it fits over the cornea of the lens and the eye instead of the whole thing like the previous lenses. And since then, other materials like plexiglasses and plastic have also been introduced, giving users the option to have a whole platter of lenses to choose from.